Great, guys, you can put your phones up.
Closer to my head. No, I forgot.
Yes. I can look yourself in a second. What? And then you can look for yourself. You did it? No, I didn't know which one there's working. I will send you down the next one. Sound good? Oh, yeah. And then your number. Yeah, let me look. So Judith, you're in number 2. And then. I'm assuming I was the last one. So you're number 33. Okay? Yeah. Oh, yeah. And if I usually don't remind you about this, but for the course syllabus, if you got that signed, you can bring that. And then Isabel, here is one for you. You can just look through there and then you do these two. Parent does that.
I have a pencil.
Yeah, there's pencils up there and the sharpener is right here.
You have a sharpener?
Right. No, there isn't, so you have to sharpen that.
All right.
Yeah, just one sheet. All right, guys, so we're gonna go ahead and get started. I typically, if you haven't had me before, I do hand out my notes. And then you can do the problems along with me, and then have that as a resource when you're either doing your homework or like if it's to study for a test or a quiz. Okay, so today we're going to talk about solving equations. This is going to be kind of a review of Algebra 1. And the first thing they talk about is different words that we use to use for addition or subtraction and multiplication. So for addition, we can say and that means add, plus, sum, increased by, or more than. All of those mean and. For subtraction, we can use minus, difference, decreased by, or less than. For multiplication, times, product. Of means, so if you said half of 60, of means multiply. Division is divided by, and quotient. So if we look at these, we just need to write the actual algebraic expression for this, okay? So they want us to do the sum of 6 times a number and 25. So sometimes you have to kind of break it into parts. So like your number can be any variable that you want to use. So let's just say X or N or something like that. So 6 times a number would be 6X or 6N. And then the sum of this and 25, what do you think we'd do? So we'd go plus 25. Okay. Then it says 4 times the sum of a number and 3. So again, you have to kind of break this up into parts. So it's 4 times this. Okay. We have to write the sum of a number and 3. Sum means add. So we could write this as x plus 3. And we want to do 4 times that. Can I just put a 4 in front, or would I have to do something else? Like if I do a 4 right here, is that multiplying 4 by all of this or just the x? Just the x. So do you know what I could do to get it? Yeah, parentheses, very good. So now I'm doing 4 times that sum. Whenever you're doing less than, you have to be really careful. When it says 7 less than, that means that you're going to have subtract 7 at the end of it. So like when you add, it doesn't matter order, but when you subtract, it does. And when it's 7 less than, you always want that minus 7 at the end. And this says 15 times a number. So what would I put right here? 15x or 15n or whatever it be that you want as your variable. Good. The product of 3 and the sum of 11 and a number. So we're going to start here. How would I write the sum of 11 and a number? Would it be times, or sum means add, right? So we're going to go 11 plus x or 11 plus n, and that does that. Now we want the product of 3 times this. Anyone have an idea what I would do? Yep, parentheses and put a 3 in front. Very good. This one says 4 times the square of a number increased by 5 times the same number. So this one, again, you have to kind of take in parts. So do you know how I'd write the square of a number? Yeah, so like x squared or n squared, okay? When it says 4 times that, I'm going to leave that 4 times till the end. And now I want to take this increased by 5 times the same number x, okay? So how do I do increased by 5 times that x? Yep, so 5x like that, okay? Now, what I'm left with is I have to do 4 times this. Do you know what I would do then? Yeah, I would have to put this in parentheses and put a 4 out front. So when it's like 4 times and then gives you a big thing, you're going to do that, put it in parentheses, and put a 4 out front. Okay. Now this says 6 times the difference of a number and 2. What does difference mean? Subtract. So it's the difference of a number and 2. So for our number, we can say x. We just said difference means subtract. And 2, so it's the number minus 2. Then it says 6 times that. So then what would I have to do? Parentheses with your 6. Okay. 2 more then. 4 times the cube of a number. Okay. So the cube of a number, how can I write that? Yep, x to the 3rd. Now, 4 times the cube of the number, 4 times this, I just put a 4 in front of it. And then 2 more than that. What do I have to do there? 2 more than would mean addition. Now with addition, it doesn't matter if you go 2 plus this or this plus 2. Addition doesn't matter where you put it. It's subtraction that order matters. So this could look like this and be totally fine also. Okay. The quotient, what does quotient mean? Division. So when I know I have division, I draw a line right away, okay? And it says the quotient of 5 less than a number. So let's start there. How would I do 5 less than a number? Yep, would it be? Yes, the number minus 5. Whenever it's less than, you have to have the minus 5 at the end. Less than, you always have the minus 5 at the end. Now, if we look back, it says the quotient, which is division, of this, which we have here, and this. So it's the quotient of this and 12. So that's taking the x minus 5 and dividing it by 12. Okay. All right, if we look here, these are some properties that you guys would have learned in geometry. And we are just going to go over these again. First of all, reflexive is any time something equals itself. And one thing I want you to notice with reflexive is you always have one equal sign. Okay, so it would be something like 5 equals 5, A equals A, 7 equals 7. Anytime the left and right side equals each other, that's reflexive. Okay. Symmetric, I want you to notice, has 2 equal signs. Okay. Symmetric, I often call the switch around property, which you can't label it that, but that's what symmetric does. With symmetric, what you do is you take an equation and you flip the left and right side. So they have A equals B, and they just took that and flipped the left and right side. Here they have 18 equals negative 2n plus 4, and they flipped the left and right side. And notice we have 2 equal signs here, 1 equal sign there. When we go to transitive, we have 3 equal signs. Okay, so in transitive, what has to be true is you're going to have 3 equal signs, and the ending of the first equation and the beginning of the second equation are going to be the same. So notice there's a B at the end of this and a B at the beginning of that. What do you do in transitive then is you cross these out and the outside 2 equal each other. Okay, so if you look at this one with an actual algebra thing, with transitive, you're going to have 3 equal signs. The ending of this and the beginning of that are the same. So it's kind of like you just cross those out, and then the outside 2 equal each other. Okay. Now, the other one that can sometimes have 3 equal signs. This one, there's not like a rule, like it can be 2, it can be 1, is called substitution. This is the harder one to recognize, but with substitution, it can be 2 different ways. One is when they went from this to this, all they did is they added 6 plus 1, which is 7. That is kind of like just simplifying. And when you kind of combine like terms or simplify, that can be substitution. Another way that you can see substitution is they could say A equals 3 and 5A minus 7 equals 10. So what they would do then is they would take this and they would take, because A equals 3 and there's an A here, it's like they pick that A out and put a 3 in there. So they would say 5 times 3. So they put that 3 in here, and then the rest of it would stay the same. So substitution is different than transitive, because transitive has to have the ending of this and beginning of that the same. In substitution, that doesn't have to be the case. Usually if you're struggling, think of substitution, and substitution can be if you take something out and put something else in. So this one has one equal sign. That should automatically tell you something. And what do you notice about both sides of this? They're the same. So do you know which one that would be? Reflexive. Good. And if you just do REF, that's fine. Now, what do you notice about B? It has two equal signs. And what does it look like they did from here to here? They flipped it, right? Do you remember what that one's called? If they switch it around or flip it, is symmetric property. Okay, just taking the two sides and flipping is symmetric. So if you go SYMM, that's good. Then this one has three equal signs. When it has three equal signs, it can either be substitution or transitive, okay? With transitive, the ending of this and the beginning of that have to be the same. And if you notice, they are. So what happens then is you kind of think of those two being crossed out and the outside two equaling each other, okay? So this one is transitive. Then if we look at D, this one says, has three equal signs again. With three equal signs, it's either transitive or substitution. Notice this one, this and this are not the same. So what that means is it's not transitive. And in this one, notice they give an expression, and then here they say H equals 24. So what you would do here is you would take this 24 and put it in for H. So it's like you pick this H out and put 24 in there. And that's what they did. So that is called substitution prop. Or you don't have to put prop. You can ignore that, actually. If you just go SUBST, that's good. What do you guys see about this one? It has two equal signs. Can you tell what they did? Yeah, so what's that called? When you switch it around? Symmetric, yeah. When you just take the two sides and switch it around or flip it around, that's symmetric. Do you think you get those? Everybody okay with that? Okay. So now if we go to this page, this should be a good review for you, but hopefully this isn't too hard for you. So we're just solving equations for X, okay? So this is something where today when you do it, I'd like to see your work when you're solving for X. A lot of times when I say show your work, I want to see the algebra that you're doing. And sometimes kids will turn in stuff and they'll do long multiplication. They'll go like 168 times 12. and they'll think that's what I mean by showing your work. This you do not have to show your work for. Or I've had kids like 5 into 1, 2, 7, 1 or something like that. This you can just punch into a calculator. You do not have to show me work. A lot of times what I want the work for is the algebra part of it, okay? And everybody shows their work a little different, so it's not like you have to show it exactly like mine, but don't just give me the answer. So you guys, would you know what to do first here? Minus the 5, okay? And then on the left side, we'd be left with 3x. 14 minus 5 is 9. And then what would I do? Divide. And x is 3. Okay. This next one, we have a variable on both sides. So what you would want to do there is just bring your variables to one side. It doesn't matter which side. I typically would bring the smaller one to the bigger one. So I'd bring that 4n over. How do I do that? Yep, so I'd subtract 4n. This is gone then. 12n minus 4n is 8n minus 3 equals 21. Then what would I do? Add 3, yep. Then on the left is 8n. 21 plus 3 is 24. Then what would I do? Divide by 8. And n is 3. Okay. Now this one here, when you see parentheses like that, the first thing you're going to do is distribute through those parentheses. So if you remember from algebra distributive property, you would go 5 times x, which is 5x, minus 5 times 2, which is 10. Then we'd go negative 4 times 2x, which is negative 8x. And then a negative 4 times 7 is negative 28. And then we have this plus x added on that we have to deal with. So the first thing that I would do here is I'd combine these two like terms. So I'd leave the 5x minus 10. What's negative 8x plus x? Yep, negative 7x, then minus 28. Now you want to bring your x's to one side, numbers to the other, and it really doesn't matter which side you bring it to. Let's bring this negative 7x over here. How would I get rid of a negative 7x? Add 7x, okay? Five x plus 7x is 12x. Minus 10 equals negative 28. Okay, then what? Add 10. I'd get rid of this. Good. And then I'm going to put this over here because I'm kind of running out of room. 12x would equal a negative 18. Then what would I do? Divide by 12. And this is one of those where you could just put this in a calculator, and I have calculators up here if you don't have one. Negative 18 divided by 12 is going to give us negative 1.5. So that would be your answer. You could have reduced the fraction also, and you would have got negative 3 over 2. So either of those would be fine. Now, when you see something like this, it looks awful because you have all those fractions, and it's nice to get rid of fractions if you ever can. So what you can do to get rid of fractions is you can look at the denominators of all of these, which in this one, it's really just 1, okay? So you look at the bottom or denominator of all those fractions, and you think, what number do all of those multiply into? And you want to try to pick the smallest number. So what you can do is think of 10. I always choose my biggest one. And I think, does 3 divide into 10? Or basically, is 10 divided by 3 a whole number? And it's not. Okay? Then I do 10 times 2 is 20. And I think 20 divided by 3, is that a whole number? And it's not. Then 10 times 3 is 30. Is 30 divided by 3 a whole number? Yes. Is 30 divided by 5 a whole number? Is 30 divided by 10 a whole number? Okay. Once you find that number, what you're going to do is take 30 and you're going to multiply it by 2/3 x. You're going to multiply it by every single term. Okay. Then I'm going to go plus 30 times 1/5 equals 30, and I even multiply it by this 2x. I have to multiply by every single term. 30 times 2x minus 30 times 3/10. Okay. Now, there's 2 ways you can do this. You could, on a calculator, type in 30 times 2/3, and I'll show it to you on a graphing. Do any of you have graphing calculators? Okay. I always have graphing calculators in this bottom drawer, and you can borrow them in class. You just can't take them. And then I have calculators up here too. So if we went 30 times 2/3 on a calculator, you would just go 30 times. And a way to do fractions on every calculator is you'd put the 2/3 in parentheses. So you'd go parenthesis, 2 divided by 3, parenthesis, enter. And that would do it for you. Okay. Do you have to do it on a calculator? No. If you didn't have a calculator, what you'd want to do is think, how many times does 3 go into 30? 3 goes into 30 10 times. So then you'd have 10 times 2x, which is 20x. Okay. When I go to this one, I could go to a calculator and go 30 times parenthesis 1 divided by 5 parenthesis. That's how I do 1/5. Okay. And that's 6. But again, if you're really good at mental math, you can just think, how many times does 5 go into 30? 5 goes into 30 6 times. 6 times 1 is 6. Okay. Now this one, nothing's going to cross out. You're going to just do 30 times 2x, which is 60x. And then this one again, you could do on a calculator. You could go 30 times 3/10. 3 divided by 10, put that in parentheses, and we get 9. So again, you would think 10 goes into 30 how many times? 10 goes in here 3 times. 3 times 3 is 9. Now we're back to a much easier equation. We have 60x and 20x. You can bring the x's to either side. I'm going to bring them over here just because then I don't have to deal with a negative, but you could certainly do it the other way. Then I'd have 6 equals 60x minus 20x is 40x minus 9. And then I would bring my 9 over to the other side. And I'd get 40x equals 15. Divide by 40. And x is, okay, so you can go to your calculator and go 15 divided by 40 and get it as a decimal, okay? And one thing I'll be showing you guys this year, if you ever want to change, if you want to go 50 over 40 and reduce it, on a graphing calculator, you can go 15 divided by 40, and there's this math key here, and if you hit enter twice, it will reduce it for you. Okay, there will be times we will use that. Today you could put it as 3/8 or as 0.375. So obviously something like this, I'm not going to give you credit, but just an answer. All right, then if we go to this last page, this is asking us to take this equation and solve for x, and then put x into this expression, okay? So we're going to take 4x plus 18 equals 25. We are going to subtract 18, and we get 4x equals 7. Then we would divide by 4. And most of you would go 7 divided by 4 on your calculator and get it as a decimal. 4 divided by 4 is 1.75. Okay. Now we're not done yet. What they want us to do then is take that x and put it in here. So I'm going to take this 1.75 and I'm going to put it in there for x. So I'd go 4 times 1.75 minus 8. So if I go to my calculator, I have 4 times 1.75, subtract 8, and it's a negative 1. So over here, it'd be a negative 1. Okay, so that's it for that. Here is your assignment. Now, here's what I want you guys to do. When you have your notebook page, okay, I want you to put either your name up here in the corner. Always put the name up there. But you're either going to do the page numbers and the problems up in the corner, or you can put your name here, and then on that top line, do the pages and which numbers I assign. Okay? And the reason I do that is then when I enter it into the grade book, I know what page you're on and what problems you did. So make sure you put your name, the page numbers, and the problems on your assignment. Did you think it was hard today? Okay, so that's your assignment. And then if you get done in class ever, you can turn it in today. Your bin is that first one. You can always turn it in today, or you can wait till tomorrow morning and turn it in. Okay? Okay.
Can I get your book?
Yeah.
And they can also borrow a graphic calculator as well.
Yep, in that drawer.
Thank you. Can I borrow a calculator?
Yes.
And grab it?
Oh, in the bottom
sorry.
drawer. There's either these or graphing.
I also grab my phone real quick. I forgot my lock.
Oh, for sure.
Can I just borrow one of those?
Yep.
Thank you.
Yes. Isabel, did you want to go get your book too? And it's Algebra 2. All right? Yeah. Okay. Yeah. No. Unless if, the class is really super good, and I might every once in a while, but not as a rule.